All right, we are officially recording. So, first, Nick, are you okay with us recording this and later posting it to YouTube?
Yes, absolutely.
All right, so welcome everybody to our second of our Magnet tutorial series. This one's going to be given by Dr. Nick Murphy, who is at the Center for Astrophysics, does a bunch of work with Plasma Pi, and is in general a lovely research software engineer. So they're going to take us through making Python scripts and packages using UV. And with that, I'm going to hand it over.
Awesome. Thank you, Mel. And I'm going to put the links in the chat again since in case anyone joined. So these are the links to install UV if you want to follow along, and then to this tutorial page in case you want to scroll up or down. So thank you all for coming. As Mel said, this is the second in the MagNetUS webinar series. And today we're going to talk about UV, which is a Python package installer and manager. And then tomorrow we're going to talk about PyTest, in particular, like writing our first software test with PyTest. So, um, so let's go ahead. There's one saying about live demos, which is never do live demos, but I'll do my best. And please feel free to ask questions in the chat or raise your hand, and then Mel or Dimitri will um, be able to call on you. All right. So if you have installed UV already, the way to check to make sure that it's working is to open a terminal or PowerShell and then do UV self version. And in this case, it's saying that I have UV 0.8.1 installed, which is the most recent release. Slightly older releases will work also. So as we're doing that, in case anyone still needs to install UV, I'll mention a few reasons why UV has taken the Pythoniverse by storm. It was only first released a year and a half ago, and despite that, it's been rapidly adopted across the broader Python community. And the vision that the company working on UV Astral has is to create a unified tool chain for Python work for Python packaging, project management, and sorts of things like that. And UV is one of the core parts of their tool chain that they're still very actively working on. So UV in particular, um, the first way that a lot of people will encounter it is that UV can be used as an alternative to pip for installing Python and also installing Python packages. And there's some reasons why UV has significant advantages over pip. Also, please let me know if the font size is too small for either of these. All right. So UV has a very excellent caching strategy. So once a version of a package is downloaded, it does not need to be downloaded again. And it also like downloads the registry information. So like what packages, versions are available and things like that. And this is unlike pip, which re-downloads dependencies for every time, for every environment that you install them for. With UV, you don't have to do that. Um, UV also has significantly faster dependency resolution than pip, and especially when we have a cache that has already been started. And it also has a lot of capabilities that other tools lack, such as resolving environments for the lowest allowed versions of all our direct dependencies, or, and this is important for scientific reproducibility, releases that are made up until a certain date. So if you want to reproduce um, results that were created 16 months ago, you can set in that date and recreate an environment that was pretty close to what it was back then. UV also has a universal lock file. It's pretty common for um, people in the Python community to use requirements.txt style files to store the different requirements for an environment. But it has some limitations because um, it a requirements.txt file only works for a single version of Python and usually, or when you have strict requirements. Um, and it sometimes only works for a single operating system. But with uv.lock, you're able to have a universal, or I guess it's strictly speaking planetary, lock file that works across different versions of Python and multiple operating systems. So it's really helpful. Um, One thing to note also is that there was a recent Python enhancement proposal that defined a replacement, a more modern replacement for requirements.txt files. So this is called pylock.toml. And perhaps the most important note of this tutorial is that Pylock would be a great name for a supervillain from a 1980s children's cartoon. All right. So we can go ahead with the tutorial. And we're going to start off by creating and managing Python environments, um, virtual environments with UV. So when most of us install Python packages, we tend to use a command like pip install astropy, for example. And by default, when we do pip install astropy, unless we did something special, this command will install astropy into the default Python installation or the system Python installation. And this usually works, but not always. Sometimes we'll run into a situation where the requirements for one package contradicts the requirements for another package. We've run into a package conflict. So suppose Plasma Pi 2024.10.0 requires AstroPi less than version 7, but SumPy, a particular release, requires AstroPi greater than or equal to version 7. When this happens, the versions of Plasma Pi and SumPy cannot be installed simultaneously into the same environment unless you're willing to intentionally possibly break things. But the way to get around this is to use virtual environments. A virtual environment in Python is an isolated space where we can work on our Python projects separately from the system installed Python. So we can have our system Python, the one that came with our computer, um, and we can have the whatever packages came with that. And then we can create our own Python environment. So if we want to install AstroPy, SunPy, PlasmaPy, NumPy, PyTest, we can create our own environment to do that in that's separate from the system Python. And this can be incredibly helpful, especially when you've been using a Python environment for a while, or if you have different projects. So now we can go on to the interactive version of the tutorial. And after you've opened a terminal and done UV self-version to make sure that it's working, let's create a directory. Let's do mkdir for making a directory. And let's call it UV underscore tutorial. And then I'll hit enter. And now I'll enter the directory with cd UV underscore tutorial. All right. So I mentioned that by default, when you install a Python package, it'll go into the system Python. We can use the which command in a Unix terminal, and this should work in, I believe this works in PowerShell also. We can do which Python, and in my case, we see that it's using a version that is not in my home directory, and this is the version of Python that CoCalc, the platform I'm using, comes with. So now that we're in this directory, let's create a virtual environment. And the way to do that with UV is to do UV venv. And this would be enough to create an environment, but let's also specify the version of Python just to make sure that we're all using the same one. And in this case, I'm going to add a flag, dash dash, Python, and then we'll use 3.13, which is the most recent release of Python. And I'll press enter. And I created an environment for Python 3.13.5, and it has a couple of commands, or a couple of um, comments. So it's saying that it's creating a virtual environment at .venv, and there's also a command to activate this environment. So let's look at the full contents of this directory with ls-a. And if you're using PowerShell, you can use dir instead of ls. And now this directory, which used to be empty, has a .venv folder that contains the UV virtual environment. So we created a virtual environment at .venv. And most of the time, we don't need to actually go into this directory. In fact, if we do go into it and change things around, chances are we'll break something. But now that we created this virtual environment, let's do which Python again. And we see that it's still the same version of Python that we were using before. And the reason is that we haven't actually activated this environment. And depending on the operating system that we're using, or if we're using PowerShell, there's going to be a different command to activate the environment. For the shell that I'm using, which is bash, off of the default on Linux, it might be ZSH for macOS, but we can use the command that came out for me, which is source.venv/bin/activate. And this is exactly the command that was printed above. So now that we've activated this, the prompt is showing that it's UV tutorial, that this is the name of the virtual environment that was created, and it's the name of the folder containing .venv. So now let's type which Python. And in this case, it's in my home directory. It's not a system version of Python. And it's in the .venv folder in the UV tutorial folder that we created. And it's the Python executable within that. So when we activate a virtual environment, we change which version of Python that we're using. All right. One thing to note is that if we open a new terminal, then we'll need to reactivate this environment. But if you want to make a certain virtual environment your default environment, it's possible to add this command to our shell configuration file. So something like .bashrc for bash. And I'm happy to talk with people about how to do that afterwards if you want to stay along. All right. So I mentioned that UV, our first experience with it, is often as a drop-in replacement for pip. So we want to install a package into this virtual environment. We can do UV pip install, and then the name of the package, which is NumPy. And I'll try to change these a bit. And then enter. And very quickly, UV ended up solving for the environment and then installing the package at NumPy 2.3.1. So UV should do this very quickly. We already activated this environment, but if we want to deactivate it, the command is deactivate. And now the change to our prompt disappeared, and we no longer have this available. So this is going through virtual environments is one of the things that we need to keep in mind before we go through and um, get to the uh, tofu and potatoes of this tutorial, which is how to create projects with UV. All right. And this is quite straightforward. It used to be horrible. Now it's a lot less horrible. To create a Python project, we can do UV init and then my project. And now it says it initialized a project called my project at this directory, this subdirectory from where we are now. So let's enter the subdirectory, cd my project, and then do ls-a or dir if you're on PowerShell. And we see now that there are a lot of different files in this that were automatically created. And the main one is main.py. This is the only Python, only file containing Python code. So this is the one that we modify to put like our new functions or um, whatever else in. And there's some other files, including pyproject.toml. Pyproject.toml is one of the most important files to remember for a Python package or project because it's the configuration file. And we'll look at that a little bit more in a minute. There are also some other ones like a readme.md, where the .md stands for Markdown. It's a type of markup language that's pretty human readable. There's .python version, which in this case probably just says 3.13. This is a version of Python associated with the project. And then there are two other files, or sorry, a directory called .git. And this is not the directory that we should never enter directly. And it's the file that says that this is now a Git repository. So it's able to be version controlled. And then there's a .gitignore file, which includes the files that we don't want checked in. All right. So now let's look at pyproject.toml. And I'll do clear first, and then cat pyproject.toml. And in this case, it has an initial configuration. Um, a toml file is essentially a file format that's often used for configuration files. And it often has like key value pairs, so name equals my project and things like that. And if we wanted to, we could add our description here. So we could edit this file directly. So now let's see what's in main.py. So we'll use cat, which is short for concatenate. And in main.py, we have an initial function. It says, when you run it, it'll say hello from my project. And then another if block, which the contents of this block get run when the file is run as a script. So if we do Python main.py, this is the file, this is what's in here will get run. And it's pretty helpful to, when we write Python scripts, to define a main function, because that way we can run it from within Python also, as well as within it, as well as a script. And it helps keep things organized. So we'll go through two ways to run this. So the first one is to use Python main.py. As we're telling Python to execute main.py. In this case, it runs the contents of this block. And when it does that, it calls the main function and prints this out to the screen. However, if we had depended on different packages, so if our main.py depended on a specific version of NumPy, for example, then Python would not go through and reinstall the packages. So you'd have to take care of that manually. We can also do uv run main.py. And in this case, it will create a new virtual environment um, for this project. And this virtual environment will contain the dependencies that, so if it depended on NumPy, the virtual environment would have NumPy be installed. So it's really handy, especially if you want to share Python projects with other people. Excuse me. And I'll pause for a moment. Are there any thoughts or questions? All right. So now we can go on and see what has changed. So let's do ls-a. And there are um, two new contents to this directory. There's .venv, which contains the virtual environment, and uv.lock, which defines the virtual environment. So if you wanted someone else to be able to use the virtual environment that you have now, you could share uv.lock with them. Excuse me again. All right. Cool. So now let's suppose we want to add a dependency to this project. So maybe we want to use AstroPy units. So we can do uv add, short for adding a dependency, AstroPy, and then enter. And then uv very quickly resolved the packages that need to get installed, and then installed all of the packages into that virtual environment. And it's now also in uv.lock. And if we do cat pyproject.toml, we now see that it has AstroPy as a dependency. So we don't need to remember the syntax of pyproject.toml to add this. We can use uv add AstroPy and it'll add it as a dependency. If we want to add an exact version of AstroPy or a different or specific constraints on AstroPy, we can do uv add AstroPy equals equals, and let's do 7.0.1. And so now it dropped AstroPy equals 7.1.0 from the environment and added 7.0.1. And we can also add and remove dependencies. So let's do uv add sunpy. And in this case, it had to install a bunch of other packages. But maybe we don't actually need sunpy for this particular project. Maybe we're not working with solar observations. Okay. And okay, cool. This froze for a second. Okay, so we added sunpy, and for this project, we don't actually need sunpy. We can do uv remove sunpy. In this case, this command will remove all the things that we just installed. So these are all shortcuts for working with Python projects. And in the past, we've had to do all of this often manually, which has been kind of a giant headache at times. But UV makes it a lot more straightforward to do that. So I'm really happy that Astral put in the work to create UV. Okay, so now we can create a Python package with UV. And again, this used to be kind of horrible, and now it's a lot less so. It's a lot more reasonable to do so. So let's go up a directory. All right, I want a question. So if two packages have the same library or package within them, and one of the main packages is removed, will the shared packages stay installed? Yes. So if we added, for example, um, request, which is a library for downloading things, as as an explicit dependency, um, but SunPy depends on request. If we remove SunPy, we would not remove requests if it was still listed as a dependency. So as long as it'll solve for an environment that matches what um, is in pyproject.toml. That's a good question. So thank you for asking that. Okay. So we did cd dot dot into the UV tutorial directory. And now let's create a Python package. So this is something that we'd be able to share on the Python package index. And so to be able to create something so that we'd be able to eventually install it with pip or UV or other package managers like Conda. And this command is similar to before. So UV init, and let's call it my package. And in this case, we will do dash dash library and enter. And now we've initialized my package at at the my package subdirectory. So now that we've done UV init my package dash dash library, we created a Python package. Straightforward as that. Um, let's go into my package and then do ls-a or dir in PowerShell. So it looks pretty similar to what was there before, except that instead of main.py, there's now an src directory, which is short for source code. And this is um, a more recent standard practice for Python packages to put the source code within an src directory. So if you see src, that's where the source code of a package is. And now let's take a look at what's in um, the src directory, and let's in particular look at the my package subdirectory. So we're seeing what's in src/my package. And there are two files. Init.py is double underscore or dunder init.py is a file that needs to be there in order for for a directory to be imported by Python. And py.typed is a probably empty placeholder file that says that that this package uses type hint annotations. And that's something that if anyone wants to learn more about that, feel free to stay after, and I'm happy to go through a few examples. So now let's create um, let's first look at what's in init.py. Oh, and Saket, do you have a question?
Yeah, thanks, Nick. I think one of the attendees, like Ransom, is our student. He has a question for you regarding packages.
Oh, if it's the one in the chat, I answered
Yeah.
that a few minutes ago.
Oh, okay. Sorry, I missed it. My bad.
Oh, You're good. Thank you for um, following
Oh,
up on that.
sorry. Yes, I was back. Yes.
You're good. You're good. All right. And oh, we're going to look at what's in init underscore dot py or dunder init. And in this case, we need to include the subdirectories. Let's do src my package, and then two underscores init, two more underscores dot py. All right. And now that eventually shows up. And init.py, in this case, has a single function, hello, and this function says hello from my package. And it has one type hint annotation, which in this case, it doesn't do anything except serve as documentation and tell Python what types we're expecting. All right. So we're still in the my package directory. And let's create a virtual environment. UVDENV. And then again, let's specify the version of Python 3.13. And now it created a virtual environment. Let's use the command that printed out here, which will be different for different operating systems. So do source.venv/bin/activate. And now the prompt was changed so that it says that my package is the active environment. So now that we created a package, we can install it into this environment. So let's do uv pip install -e dot. And what this command does, uv pip install will install a package into the virtual environment in the directory or the one that was activated. The -e is short for editable. So if we change the contents of the source code, if we add some new functions, we don't need to reinstall the package. We might need to re-import it, but we won't need to reinstall it. So that would make it editable. So if you're actively working on a Python package, then the -e flag really helps. And dot here corresponds to the directory that we are in. So we're saying, let's install the package in this directory into the local virtual environment and make the installation editable. And now it did that really, really quickly. And now we have my package installed. And now let's enter Python. And let's try importing it. So we can do import my package. And it imported. Yes, it worked. Okay, good. First time I tried this tutorial, I had one of these commands wrong and I was in the wrong directory. It didn't work. So happy when things work. Now that we have my package imported, we can do my package.hello. And it says hello from my package. So, and if we wanted to, we could add more functions to my package. We can add more files, more modules, and then be able to import that. I'm happy to talk more with people afterwards to do that. So this was a somewhat quicker than anticipated tutorial, which I guess is a good sign for creating our own Python package. And like I said before, the process of doing this has historically caused like 17 headaches simultaneously. the process of creating a Python package has historically been kind of painful, but UV has made it a lot more straightforward to create our own Python projects, um, our own Python packages, compared to the situation before. It automatically creates a lot of the files. Uh, and so that's that. So I'm happy to pause or finish up now and take time for discussion and questions. And tomorrow we're going through the process of creating our first software test with PyTest, and we'll use UV just a little bit in that. Um, if there were two packages that I would recommend that scientists learn, two Python packages, the first would be NumPy, because you need that to do anything in science. And the second would be PyTest, because software testing is really important. Whether we're working on projects on our own or if we're sharing, writing automated software tests makes can make our lives so much incredibly easier um, than having to manually test code and possibly breaking things. So, so that's that. And thank you for coming today. And I'll see you. I'll stick around for a while. And um, please stop by tomorrow also for um, the PyTest shindig. Great. Thanks. And we have another question in the chat. It seems like you make a different virtual environment for every project, in which case, why is installing the package you're making -e2, the virtual environment, useful? Won't Python see it anyways, since it's in the directory you're running from? Uh, with the SRC setup, um, sometimes it doesn't recognize it as a package. Often you need to do the installation in order for Python to recognize it as a package. Um, if you just had the name of the package as the directory and imported it that way, then this command would work. But with the SRC layout, um, it doesn't. And there's some pitfalls, some potential pitfalls of not having an SRC directory containing the source code. Um, Sometimes you can be running tests against like different versions of packages than you think. Um, and sometimes there's stuff you have to do in order to, like if you have C code in your Python package, then installing it, um, make sure that it gets compiled and linked correctly. Yeah, thank you for that question. All right.
I don't see other questions in the chat, so if people have questions, they maybe can ask them either by raising hand or just speaking up.
I have another question. Can you expound a little bit about the benefits that you see of UV versus like Conda for package management, besides that it's faster to resolve dependencies? Like, is there anything functionally that it can do that like Conda or pip can't do? What are the coolest ones like that?
Yes. So there are trade-offs with using different package managers, and I'll start with one thing that UV and pip aren't able to do that Conda can. And Conda is able to distribute packages that are in different languages, so it's not limited to Python. UV has the first part is that it's really, really fast. Pip does not have the capability to create a package. So pip itself isn't like a project manager. I don't believe Conda has that capability either, but I could be mistaken. Um, and UV also has some features that, um, like being able to do use different resolution strategies. So if you want to solve for the lowest allowed versions of all our direct dependencies, um, then you can use UV's lowest direct resolution strategy. And it also has the capability to create an environment and require that everything was released before a certain date. So it won't include stuff that's after that date. And these are both useful. I use the first really often for testing Plasma Pi. And the second is useful for things like scientific reproducibility, where if we want to, if someone has an old Python script and we want to use the same versions of NumPy and SciPy and AstroPy or whatever else, then this can help create an environment that the script is more likely to work in. And there are also other things in UV that um, I didn't even get into the workspaces um, for this, but the universal log file I found to be really helpful. And it also combines a whole bunch of different tools. So I do highly recommend looking into more details in like UV's capabilities. A lot of the functionality exists elsewhere, but UV puts it all in one place and has a really nice interface and incredibly excellent performance. So I was really excited when it came out. And thank you for that question too. All right, any other thoughts or questions?
All right. If not, thank you, Nick. We appreciate it. It will be the same Zoom link for the PyTest tutorial tomorrow, and we will work on getting this uploaded to the YouTube later today.
Awesome. Thank you so much, everyone.
Thanks, Nick.